Welcome to another exciting physics video brought to you by Vision Concept Academy. In this video, we'll be looking at reflection of light on plane surfaces. Okay, so we saw there are two kinds of objects emitting light, or by the nature of their interaction with light. You have the luminous objects and the non-luminous objects. Okay, so the non-luminous objects are just what we'll be studying here now, because they are like reflectors. They are reflectors. They are reflectors. They are reflectors. The luminous one is the one that generates light, generates rays of light. So recall that we said things like candle, sun, fireflies, and so on, light bulb. They produce light and they emit light. So the luminous objects are the ones that emit light on the non-luminous objects, but non-luminous objects reflect light. So we're going to be studying the reflection on light on plane surfaces. If, for instance, a non-luminous object is very smooth, I want to use this plane. So the ray of light falling on this object, because this object is a non-luminous object, it will reflect the light or the ray. So no matter how many ray of light that comes in like this, there will be a corresponding reflection. There will be a corresponding reflection. This one too, sorry, it's regular. Please, I'm trying to, as much as I can, represent it. It's regular. Very, very regular. Very, very regular. Geometrically speaking. All of them. It's actually more complex than what I'm trying to depict here. But because of clarity, for us to understand the patterns, we just use as few lines as possible. Because if you check the particular nature of matter, every particle on the matter will reflect light. Imagine a matter that is made up of many particles packed together to form the physical property of that matter. All the particles will emit light. They will emit rays. You understand? So it's more complex than what I'm showing here, but we're trying to use few rays of light as much as possible so you can see the pattern. You see, so this one now on this non-luminous body is what we call regular reflection. Why? Because the particular luminous object is a smooth object. So this is a regular reflection. So this is opposed, just note this diagram. This is opposed to an irregular reflection. Why? Because the surface that is being reflected on is not smooth. So I have this surface like this. This is also on that non-luminous surface. So this light ray comes like this. It reflects this way. Why? Because it's going this way. It comes like this. It reflects this way. See, it's not regular again. It's irregular. Reflects this way. See how scattered it is. The incidents, they are trying to be normal, but this one is just scattering. You see how they are scattered. So this is from irregular. It's irregular reflection. Why? Because the nature of the non-luminous material that's reflecting is not smooth. It's not a smooth. So you can call it also a diffused reflection. You can call it a diffuse reflection. So you have irregular reflection because of a smooth surface, and irregular or diffuse reflection because of a rough surface. So we go into the law of reflection. So there are laws of reflection. So before we go into the laws of reflection, I would like to also explain what a plane mirror is. What's a plane mirror? What's a plane mirror? So a plane mirror is just a glass. It's a glass that has one side coated with a silver. Hmm? So just have a glass like this. It's a glass. It's a glass. So this actually a mirror, but you now coat one side. So once this side is glass, why are you coating this side? You are coating this side because that side will serve as the screen to receive any image reflection. That's why you coat that side. If you don't coat that side, it becomes just a glass. And the glass, the glass can have ray go through it. Refraction. That's what we call refraction. There are different phenomena. We're looking at reflection now. Reflection. Why? Reflection is for non-luminous objects. You understand? If ray of light hits it, it bounces back, change direction and bounces back. Light must always travel on a straight line. We have said it before in the previous video that with the pinhole camera, we have been able to study the nature of light to tell you that light travels in a straight line. If I put pinhole camera like this, I mean a pinhole lamp like this, and I put cardboard, and put holes on the cardboard like this. First of all, I have to align this cardboard. I will align it. How will I do it in the lab? How will I do it? What I will do is that I will put a string like this through the holes, stretching it. Put a string like this, stretching it until it's straight. When it's straight, I can name it. All this cardboard has their placeholders so that they don't move. They are placeholders, they don't move. You understand? They don't move. So when I straighten it, I now put a light source here. I now go to this side and view eye from there. If I can see the light, it means that the light is straight. And if I remove any of these cardboards, you understand, I will not see the light again. It shows that this light is traveling on a straight line. Understand? So light rays is always going on a straight line. So for reflection, it hits the non-luminous surface and bounces back, still on a straight line. Though there's a tendency for you to continue. We'll study that tendency again. That tendency for you to continue. This one will produce what they call virtual images. We will come to all these things. Just relax. We'll come to all these terms, virtual image. And this one will still go and form a real image somewhere. Real image. We'll come to all this. Please just relax. So this is a mirror. A mirror is formed when a glass is coated on one side. Why are we coating it on one side? So that you can receive the image. If not, you just have forming virtual image for plain glass. So that's a plane mirror. But what we're looking at now is the laws of reflection. The laws of reflection. Okay, so I'm going to quote the laws for us. Okay, so this is the laws of reflection. The laws of reflection. It states there are two sides. It states number one, the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. It looks like this. This is the plane. So let me say this plane is a mirror that is coated, a glass coated with silver coating on one side. So it's a plane, all lie on the same plane. So there is the angle of incidence for a particular ray. There are many rays coming from the object that is looking at this glass, this mirror. There are many rays, but we are looking at one, so we don't confuse it. We're looking at one ray from the object. So this is the incident ray. But when it comes like this, there is a point we call the normal. Let me put it here. Normal. That point, that's normal from geometry. Normal is perpendicular at right angle. Just have it in the back of your mind that normal is perpendicular. Let me do it well so that it looks, the geometry is correct. So this is the incident ray on this point. Then the normal. So when this is incident ray I, when it comes on this plane, there's a normal already. That normal is virtual. It's not something that's not part of the ray. It's geometry. There's a line that is normal, perpendicular to this one. So the incident ray hits this point here, and it's reflected from this point again. So that first one is saying that the incident ray, this one, the reflected ray, this one, and the normal all lie on the same point at the point of incidence. So this is the point of incidence. They are all together. Second law says that the angle of incidence, let me call this one I degree, and the angle of reflection, the angle is the angle formed. Angle of incidence, angle formed when angle formed in between the angle of incidence, the incident ray and the normal. Okay, I'll take it again. The angle of incidence is the angle formed between the incident ray and the normal. Let me name this one normal here. N normal. Come here. N normal. This one reflected ray. This one incident ray. So the angle of incidence is equal to the angle of reflection. So this is the law of reflection, or the laws of reflection. If this ray is continued like this, because like we said that light tends to continue on a straight line, except being interrupted. So let's say that there was no mirror, no plane surface here, no non-luminous surface here. This thing would have continued like this, on a straight line. From geometry, this is a straight line again. It's a straight line again. Now the angle that is formed between this supposed line that is continuous and the new line that's formed because of this thing. Let me do one angle like this. There's an angle that is formed in between this incident ray that continues, that would have continued if there was no interruption, and the one that came from the interruption. This interruption, there was this thing is the interrupter. Is the surface that caused the reflection, the non-luminous surface. The non-luminous surface. It reflects the ray. So this is the one that caused it. So if this one caused this thing now, there's on our line like this, the angle between this one that continues like this and this one that came because there was interruption is called the deviation. It was supposed to continue like this, but something that happened, not deviated. So that's deviation. From geometry again, from geometry, we know that if this is a straight line, let me call this A, O, B. AOB is a straight line, right? From geometry, comma, angle I plus angle R plus angle D is equals to 180. Am I right? Yes, I'm right. This angle and this angle are 180. But we know that from second law, I and R are the same thing. So let me call I and R equal. From second law now, I degree plus I degree. They're the same thing. Plus D is equals to 180. So this D is actually 180 minus 2I. So that's the relationship. This D is what? Angle of deviation. Let me find it here. Angle of deviation. What deviation? The deviation that happened because this light was interrupted from, this ray was interrupted from continuously going on a straight line by this guy, this non-luminous mirror. It changed the direction of the ray. So that's how I have this. So deviation for plane mirror, this is the relationship. We are going to be looking at further when we look at regular prism. We will see how we derive all those things. When you have rectangular prism, you have a normal incident ray, reflected ray. You understand? Now this one this is the normal that continues like this. This was supposed to continue, but there was a refraction and another refraction. When we look at refraction of light, we study rectangular prism. But now this is the foundation for plane mirror. The relationship between angle of deviation and the incident ray is D is equal to 180 minus 2I, where I. Okay, so we are going to be looking at the principle of reversibility of light. Okay, so really, this principle tends to uh, uh, say that light rays can be reversible. That is, if I have a plane surface like this, you understand, and I have a light source here. This is a light source here. So the ray of light from this light source incident on this is reflected this way. You understand? And it forms an object here or an image here. You understand? I can still be at this point and take this as my incident and this as my reflection, reflected ray. That means incidents at this point can become reflected at this point. Principle of reversibility. I can reverse the way I see the light ray. So if my point of reference is here, this is the incident ray. I can still maintain this ray structure and be here, and my point of incident is also here. So that is the principle of reversibility of light. So it's a general principle in optics known as principle of reversibility of light. Understand? This principle states that the path of the light ray is reversible. This is easily seen when we consider the reflection as shown in this mirror. This is what I'm seeing. So I can be at this point and see that the ray is incident here, and at this point it's also incident here. So when it's incident here, this becomes reflected ray, and when it's incident here, this becomes reflected ray. So let's see how images are formed by a plane mirror. How images are formed in a plane mirror. So how do we form image in a plane mirror? So this is the mirror, for instance. This side is the coated side of the mirror. Let's say, for instance, now I have an object here. Let me put a candle lighting here. This is a candle lighting here at this point. So this candle is looking at this mirror. This side is coated, remember. So if I am here, let's say, for instance, somebody is here, it's an eye. This is an eye. It's an eye looking at this object. Normally, this object, the ray from this object, from this light source here, from this tip here, this object, let me call it object, please. So the ray is incident like this, and there is a tendency for it to continue this way. You understand? If there was no interruption, continue this way. Meanwhile, the eye ray comes like this and reflected like this. This one too comes like this and reflected like this. Don't mind my unscalable. Okay, so these are rays now. I'm just drawing two so that I don't make it complex. So this is incident and reflected. So the light, the rays from your eyes incident on the mirror and reflected, to this point. And this same point is incident on this and refracts into this point. Now, if this one continues like this, virtually, they go and form what is here. This is a virtual image here. So this is what you are seeing inside the mirror. You are seeing this inside the mirror. Why? Because of this interactions of rays. You are seeing that inside the mirror. So it's virtual, it's not real. This is the object, but the image is not real. Understand? Because the lines forming all these images are coming from lines that did not actually are virtually imagined. They are lines that would have continued if there was no interruption, but you are seeing them here. Okay, so this is how images are formed. Now, there are two concepts here. There is the virtual image and the real image. So a virtual image is the image that cannot be caught on the screen. So this is not caught on the screen. This is the screen. It's not caught on the screen. You understand? What is the difference? What's the difference? The screen is like the cardboard, where if, for instance, a shadow is cast, you understand? You see that image cast on it. But now it's not a kind of shadow thing. It's a light rays interacting and giving a perception that this thing is this one. You understand? So it's virtual. It's not real. It's not real. So it's actually one that cannot be caught on the screen, and it's one through which the rays of light do not actually pass, but which nevertheless visible to the eye. So it's visible to the eye. You can see it. But on the other hand, a real image is the one that can be caught on a screen, like the one I said for shadow cast on a screen. It could be cardboard paper, you know. So light rays actually pass through a real image to form the shadow or to form the object, you know, on the screen. So we have seen the difference between real image and virtual image. There's what they call lateral inversion. This mirror has a way of producing an effect known as lateral inversion. Lateral inversion. So what is it? It's actually the mirror giving the image that is formed by the object a lateral inversion. A lateral inversion. Have you ever stood in front of a mirror, a plain mirror, and you lift your right hand up? Your image that is formed there will appear to be lifting its left hand. So you are here. See you here. And you come up and lift your right hand up like this. You have a mirror in front of you. This is a mirror, right? So the mirror will lift its own left hand. So this is mirror, and this is you, object, and this is image. So you are lifting your own right hand. Do you not? Mirror is lifting its own left hand. So this is lateral inversion, actually. So you see that any image that is placed in front of a mirror is laterally inverted. So if they are asking you one of the phenomena of a plane mirror, it is lateral inversion. So we can quickly summarize the characteristics of the image formed on a plane mirror. This image formed, what are the characteristics of the image formed on a plane mirror? Number one, characteristics of image formed by a plane mirror. Number one, it is the same size as the object. Same size as object. So what does that do to magnification? Magnification is 1 for plane mirror. So the same size. The image, this C and this is the same size. So if you are standing in front of a mirror, it is the same size. That's plane mirror. It's not, if you have concave or convex mirror, that's a different thing. We're going to be studying those kind of mirrors later. Okay, so number 2 characteristic is that it is virtual. It is virtual. The image is virtual. So we see that this image virtual is being formed by imaginary lines that are supposed to have continued, if not for this interaction. We're imagining that, okay, light traveled on a straight line, but because of this interaction, it didn't travel again this way. That is why it's virtual. So number 3 characteristics of image formed by plane mirror, it is laterally inverted, lateral inversion, or laterally inverted. Okay, I've discussed that. I've explained lateral inversion here, the mirror effect, plane mirror effect. Then number 4, it is far behind the mirror as the object in front of the mirror. That's the same size, the same distance. D1 and D1, the same distance from the mirror. So here to here, it's same as here to here. So it's the same. Okay, it is as far behind the mirror as it is from the mirror. So what that means is that object distance and image distance are the same. Then finally, it is upright. It is upright. You know, we talked about the pinhole camera in the previous video. And the pinhole camera produces an inverted image. But for the plane mirror, the size of the image and the image is upright. It's upright, not inverted. It's not upside down. And the distance from the mirror is the same thing as the distance from the object to the mirror. The lateral inversion, of course, that's sideways, lateral, sideways, that the side. This side comes this side, it twists. So you are lifting your right hand up as the object, looking at the mirror, while your own image is leaving its own left hand. Okay, so it is virtual and the same size as the object. So kindly subscribe to our channel. I hope this video has been informative for you. I'd like to thank you for viewing.